So the s orbital has one orientation in space. The p orbital, you just have to memorize, has three orientations in space. The d orbital has five, and the f orbital has seven. So what we're going to do is we're going to refer to these orientations in space, to make it more simple, as their mailbox. So if I ask you how many boxes can we draw for an s orbital, you want to tell me one. So you would draw your one box, and then you're going to number your box. Just like your mailbox has a mailbox number, these boxes are going to have box numbers. So since S has one orientation, we draw one box. Now remember, an s orbital, we just learned, has an L quantum number equal to 0. So the value for M will go from negative L to positive L. Well, there is no negative 0, so we're just going to number the mailbox for the s orbital. It always gets a 0. There is no positive or negative L. All right. The p orbital has three boxes, or three orientations. So you would draw your three mailboxes, and you would then want to number those three boxes. Now remember, if you're a p orbital, L always equals 1 for the peanut-shaped orbitals. So since the value for M can go from negative L to positive L, and L here is 1, we're going to number our mailboxes. Negative 1, 0, 1. Look, we have exactly three numbers for your three boxes. For the D, we said the d orbital has 5 boxes that we can draw. So you would draw your 5 boxes, 1, 2, 3, 4, 5. And then you want to number your boxes. So when you get ready to number your boxes, remember, for the D, L always equals 2. So you're going to number your boxes from negative 2 to positive 2. So you'll say negative 2, negative 1, 0, 1, and 2. Finally, F has 7 boxes. So you would draw your 7 boxes for your F orbital. 3, 4, 5, 6, and 7. And then, of course, you want to number your mailboxes again. Since an F orbital always has an L quantum number of 3, then you're going to number from negative 3 to positive 3. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Again, y'all, these quantum numbers, when we find them, we're actually going to find them all at one time. But right now, I'm talking about each quantum number separately because it's kind of like putting a puzzle together. So it won't make a whole lot of sense right now, but once we get all the quantum number information and we start finding the quantum numbers, it's actually pretty easy to find the quantum numbers for each electron. All right, we have one last quantum number to talk about, and that is your spin quantum number. The spin quantum number is given a letter S. S for spin, okay? So just remember S and spin. What this tells you is it tells you the direction that the electron is spinning in. Now, there's only 2 directions the electron can spin in, either clockwise or counterclockwise. So your electron can either spin in a clockwise rotation or it can spin in a counterclockwise rotation. So if your electron is spinning clockwise, the spin quantum number is going to always equal to positive 1/2. And you do have to put the sign because that gives you the direction of the spin clockwise. If it's spinning counterclockwise, we say negative 1/2. And again, you do have to put the negative because that gives you the direction of the spin. 2 electrons can fit in each of our homes. So remember I said we draw boxes for the orbitals. 2 electrons will be able to fit in each box. And when the electrons pair up, they must pair up with opposite spin. So when we put our electrons in our boxes, the way we represent our electrons is we use arrows. The first arrow always points up, and that represents your clockwise spinning electron. So if you're going to be putting your electrons in your boxes that we draw, this would represent your positive 1/2 spin, and then the negative 1/2 spin would go in. The boxes can hold at most 2 electrons, and they must have opposite spin when you place them. The first electron always points up, and then you place the remaining electrons in. I want to go back to the mailboxes that we drew on the slide for the magnetic quantum number, and let's just fill in some of the electrons. Now remember, the electrons are not always at home. They're only at home 90% of the time. So if you look at here at your S orbital, it has one box we said we could draw. So the most electrons that can fit in that one box are 2. The up arrow always goes in first, and then you would place your down arrow in. Now just for simplicity, I'm going to call the up arrows the wives, and the down arrows are the husbands. 2 electrons live in each box, and they must have opposite spin. So one's the wife and one's the husband. All right? If you go to your p orbital, one of the rules we're going to learn is that all the wives have to come home first. So if you were going to fill up all 3 of your p boxes here, you would have to make sure you put in your up arrows first. So wife number 1, wife number 2, wife number 3. They have to come home first before any husbands come home. Then the husbands. Down, down, down. 6 total electrons can fit in those boxes. For your d orbitals, you would go up, 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 and then down, 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 down. In the d orbital, since there are 5 boxes, each box can hold 2 electrons maximum. That means we could fit 10 electrons in those boxes. Finally, for your f orbital, you could fill in total 14 electrons. Now, when you fill in your wives, up, 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 up. 7 wives, and then your husbands are allowed to come home, down, 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 down. All right, so we've talked about the 4 quantum numbers, and now we're going to tie all this together and then do some examples. Let me just review with you both. The n quantum number is your principal quantum number. It represents the energy level. And it corresponds to the period on the periodic table. The L quantum number is called your orbital quantum number. Remember, L and orbital end in an L. This tells you the shape of the orbital. So we only have S, P, D, and F orbitals. So if we have an S orbital, we said L always equals to 0. L equals 0 means it's an S orbital. So that number, the 0, describes the shape of the orbital. For the p orbital, L is always equal to 1. For the d orbital, L is always equal to 2. And for the f orbital, L is always equal to 3. Again, if you trace a sphere, you get a 0. That's how I remember that. For the p orbital, 1 peanut shape makes the p orbital. That's how I remember that. The d orbital, it takes 2 of your peanut shapes to get your d, so L equals 2. And for the f, 1, 2, and 3 peanut shapes, so L is equal to 3. Again, these are ways that I remember the L quantum number. Hopefully it will help you remember it too. All right, once you know the orbital shape, then you're going to draw your boxes. So draw your mailboxes.